If Windows updated in the last several days and your machine has felt different since, slower, less stable, behaving in ways it didn't before, there is a specific reason. It has a specific name. And there is a specific thing you can do about it right now before the situation gets worse. The update is KB5074109. It landed through Windows Update as a cumulative patch. It installed silently on the vast majority of Windows 11 machines without any opt-in, and the reports coming in from users across multiple hardware configurations describe a consistent set of problems that range from annoying to genuinely disruptive. If you haven't checked whether this update is on your system yet, pause everything and do that first. Press Windows and R simultaneously. Type WinVer, hit Enter, then open Settings. Windows Update, Update History, and look for KB5074109 in the list. If it's there, this video is exactly for you. If it isn't there yet, watch anyway, because what I'm going to show you in the third part of this applies to every update Microsoft will ever push to your machine, not just this one. Let me give you the precise picture of what this update contains and what users across multiple hardware configurations are reporting since it landed, because the gap between what Microsoft's update description says and what's actually happening on affected machines is significant. Microsoft's official description of KB5074109 follows the standard cumulative update template: security fixes, quality improvements, and patches for previously identified vulnerabilities. That description is accurate as far as it goes. What it doesn't describe is the behavior that a growing number of users began documenting within 48 hours of the update's release. The most widely reported issue involves system boot times. Users on the Windows 11 subreddit, the Microsoft community forums, and the dedicated Windows Update tracking thread on Bleeping Computer, which is one of the most reliable community sources for real-world update impact reporting, began posting within 2 days of KB5074109's release, describing cold boot times that had increased by between 30 and 90 seconds on affected machines. Not on every machine. The reports cluster around systems running AMD Ryzen processors in the 5000 and 7000 series, and systems with NVMe drives using certain controller firmware versions. Intel-based machines appear less consistently affected based on the community reporting pattern, though affected Intel configurations have been documented as well. The second cluster of reports describes network adapter instability, specifically users on machines with Intel Ethernet adapters. The i212PHY and i225MVI controllers in particular, which are among the most common in consumer desktop motherboards, are reporting intermittent disconnections after KB5074109 installed. The connection drops are not consistent. Some users describe them as occurring once every few hours. Others describe them as frequent enough to make video calls unreliable. The pattern matches a class of issues that Windows cumulative updates have triggered. Before, KB5039212, released in June 2024, produced a nearly identical Intel Ethernet instability pattern that Microsoft acknowledged and addressed in a follow-up patch released 3 weeks later. That precedent matters because it establishes that this is a known failure mode in Microsoft's update process, not a coincidence. The third reported issue is more diffuse, but affects a broader range of hardware. Users are describing elevated CPU utilization at idle, processes like system and compressed memory and the Windows Update Medic service running at higher background percentages than before the update was installed. On machines with 8 GB of RAM, this background overhead compounds the memory pressure that Windows 11 already creates at that configuration, pushing some users into page file territory during tasks that hadn't previously caused that behavior. A freelance video editor running a mid-range Ryzen 7 machine documented before and after Task Manager screenshots on the Microsoft community forum showing idle CPU utilization jumping from approximately 4% to between 11 and 14%, following KB5074109's installation, with the increase persisting through 2 reboots. Now, I want to be direct about the evidence framing here. These are user-reported issues aggregated from community forums, not a formal Microsoft acknowledgement. Microsoft has not, as of this recording, published a known issues entry for KB5074109 in their Windows Release Health Dashboard. That absence does not mean the reports are wrong. KB5039212's network issues were being reported by hundreds of users for over a week before Microsoft added them to the known issues page. It means the confirmation is lagging the problem, which is a pattern, not an exception. According to Windows Update researcher and Bleeping Computer contributor Lawrence Abrams, who has covered problematic cumulative updates extensively, the gap between community-reported issues and official Microsoft acknowledgement on recent cumulative updates has averaged between 1 and 3 weeks. You don't have 1 to 3 weeks to wait if your machine is currently affected. Think about what that means practically. An update installed on your machine without your active consent is producing documented, reproducible problems on a significant subset of affected hardware. The official channel for acknowledging those problems is running weeks behind the community documentation, and the default Windows Update configuration gives you no mechanism to pause, evaluate, or decline individual updates before they install. You are downstream of a pipeline that moves faster than its own quality control, and right now, your machine may be showing you exactly what that looks like. Before we get to the fix, you need to understand why this keeps happening. Because KB5074109 is not an anomaly, it is the latest entry in a pattern that goes back years and shows no sign of changing on its own. Understanding the pattern is what motivates the preventive steps in the third phase of the solution. So stay with me here for a few minutes before we get hands-on. Microsoft's cumulative update model was designed around a genuinely reasonable premise. Security patches need to reach the maximum number of machines as quickly as possible, because the window between a vulnerability being public and it being actively exploited is often measured in days rather than weeks. Forcing updates closes that window. The intent is defensible. The execution has a structural flaw that Microsoft has never fully resolved. The flaw is testing coverage, Microsoft's Windows Insider programs, and its internal testing infrastructure test updates against a representative but finite set of hardware configurations. The real-world Windows installed base runs across an effectively infinite combination of hardware vendors, driver versions, firmware revisions, third-party software configurations, and regional Windows variants. The interaction surface between a cumulative update and that full range of configurations cannot be fully tested before release. Microsoft knows this. The response to it is staged rollouts, releasing updates to a percentage of machines first and monitoring telemetry for error spikes before broadening the release. In principle, this should catch widespread issues before they reach the full user base. In practice, staged rollouts have repeatedly failed to catch issues that affect specific hardware subsets. KB5074109, released in January 2024, failed to install correctly on machines where the Windows recovery partition was below a certain size, affecting a large number of systems that had been in use for several years, and produced a persistent 0x800700643 error that Microsoft took over a month to properly address. KB5074109, released in August 2024, triggered blue screen of death events on machines running certain third-party security software, including configurations that were neither unusual nor unsupported. In both cases, the staged rollout telemetry either didn't catch the issue quickly enough, or wasn't acted on before the broader release proceeded. The commercial reality underneath this is straightforward. Microsoft's update pipeline is also the delivery mechanism for feature changes that serve Microsoft's product roadmap. Copilot integration updates, telemetry infrastructure changes, the quiet additions to Windows data collection surface that we've covered in previous videos. Slowing the update pipeline to improve quality testing also slows the delivery of those product changes. The incentive structure does not favor caution. It favors speed. And the cost of that speed is borne by users on the receiving end of patches like KB5074109, not by the teams that shipped them. You're not overreacting by wanting control over what installs on your machine. You're responding rationally to a system that has demonstrated repeatedly and documentably that it prioritizes its own delivery schedule over your system's stability. Here is the complete response. 3 phases. Removing the update from your system right now, repairing anything it may have disrupted, and configuring Windows so that a bad update never lands on your machine silently again. Phase 1 is removal, and it is more straightforward than most people expect. Open Settings and go to Windows Update, then Update History. Scroll through the list until you find KB5074109. It will show the installation date alongside it. Click Uninstall Updates at the top of the page. Windows will open the Legacy Control Panel Uninstaller view filtered to recently installed updates. Find KB5074109 in the list, right-click it, and select Uninstall. Windows will ask you to confirm and will then begin the removal process. On most systems, this takes between 5 and 15 minutes and requires a restart. Let it complete fully. Do not interrupt the restart cycle. When the machine comes back up, go to Windows Update History again and verify that KB5074109 no longer appears as an installed update. It should show as uninstalled or simply be absent from the installed list. If you don't see KB5074109 in the control panel uninstaller list, there is an alternative method. Open the Start menu, search for Command Prompt, right-click it, and select Run as Administrator. Type the following command exactly: wasa uninstall KB5074109 and press Enter. The Windows Update. Standalone installer will open and walk you through the removal. This method works on cases where the standard uninstaller UI doesn't surface the update correctly, which happens occasionally with cumulative patches that install components across multiple system locations. A third option for users comfortable with a more direct approach: open Settings, System, Recovery, and click. Go back under previous version of Windows if it's available. This option appears only within 10 days of a major update and restores the previous Windows state entirely, not just the specific patch, but the full system snapshot before the update applied. If KB5074109 installed within the last 10 days and you've been experiencing issues since, this is the most complete rollback available. It does not affect your personal files, but it will remove any applications you installed after the update date, so check what you've installed recently before proceeding. Phase 2 is Repair, and this phase applies specifically if you've been experiencing the network adapter instability or elevated CPU utilization issues since KB5074109 installed. For the network issue, even after uninstalling the update, the driver state for affected Intel Ethernet adapters sometimes remains in an inconsistent configuration. Open Device Manager by right-clicking the Start button and selecting it from the menu. Expand the Network Adapters section. Right-click your Intel Ethernet adapter. It will be labeled with the specific controller model, typically Intel Ethernet connection I219 or similar, and select Uninstall Device. Check the box that says Attempt to remove the driver for this device and confirm. Then go to Action in the Device Manager menu bar and select Scan for hardware changes. Windows will reinstall the network adapter with a clean driver state. This resolves the intermittent disconnection issue in the majority of reported cases. For the elevated CPU utilization issue, the culprit in most documented cases is the Windows Update Medic service and related update infrastructure processes that KB5074109 appears to leave in an elevated activity state on some systems. Open the Start menu, search for Task Scheduler, and open it. Navigate to Task Scheduler Library, then Microsoft, then Windows, then Update Orchestrator. You will see a list of scheduled tasks related to Windows Update activity. Right-click each task and select Disable temporarily. You will re-enable these in Phase 3 when you configure a managed update schedule. This is a temporary state to allow the system to settle after the problematic update's removal. After disabling these tasks, restart your machine and check idle CPU utilization in Task Manager. In the majority of reported cases, the elevated baseline returns to normal following the uninstall, and a clean restart without the update infrastructure tasks running in the background. Phase 3 is the preventive configuration, and this is the part that matters as much as anything else in this video. Because KB5074109 will not be the last problematic cumulative update Microsoft ships, and the default Windows configuration will install the next one just as silently as it installed this one. The most important change you can make is switching Windows Update to a managed schedule that gives you a buffer to evaluate community reports before patches install. On Windows 11 Pro, go to Settings, Windows Update, Advanced Options, and set the active hours range to cover your full usage window. This prevents restarts during your working hours but doesn't pause updates. More usefully, click Pause Updates and set a 1 or 2 week pause. Use that window to check Bleeping Computers Windows 11 update coverage and the Microsoft Windows Release Health Dashboard for any known issues entries before allowing the update to install. On Windows 11 Home, the pause option is available for up to 5 weeks through the same settings path. Use it as a default habit, not as a one-time response to this specific situation. The second preventive step is enabling the Windows Update notification setting that most users don't know exists. Go to Settings, System, Notifications, and scroll down to find Windows Update in the app notification list. Ensure notifications are enabled. Then go back to Windows Update, Advanced Options, and turn on Notify Me when other Microsoft products need to be updated and get me up to date. Counterintuitively, being more informed about update activity gives you more decision-making surface, not less. The third preventive step is bookmarking 2 resources and actually checking them before allowing major updates to install. Search Windows Release Health and bookmark the Windows 11 page specifically. This is Microsoft's official Known Issues Tracker and is updated when problems are formally acknowledged. The second is Bleeping Computers Windows 11 News section, which typically has community-sourced issue reports days to weeks before Microsoft's official acknowledgement appears. Checking both before unpausing a pending update takes under 5 minutes and has a meaningful track record of helping users avoid exactly the situation KB5074109 created. Go back to Task Scheduler now and re-enable the Update Orchestrator tasks you disabled in Phase 2. With your pause window configured, the update infrastructure can run without immediately installing pending patches, and you want it functional for when you do choose to apply updates. One note on scope. If you're on a work-managed machine where Windows Update is controlled by your IT department's policy, the pause and scheduling options may be unavailable to you. And the uninstall of KB5074109 may require IT involvement depending on your organization's device management configuration. The repair steps in Phase 2, the network driver reinstall and the task scheduler adjustment, are generally within scope for user-level action, but check your acceptable use policy if you're on a corporate device. Everything in this walkthrough is designed for personal machines where you are the administrator. The update that caused this problem was delivered to your machine without a meaningful warning, without a staged rollout that gave you time to see community reports, and without a simple one-click rollback that Microsoft surfaces anywhere obvious. And every one of those things was a choice. Not a technical limitation, not an unavoidable consequence of operating at scale, a choice about whose interests the update pipeline is designed to serve and on what timeline. The 3 phases I walked you through today: remove the update, repair the damage it may have caused, and configure your system to give you a decision window before the next one installs, are your practical response to that choice. They don't require you to disable Windows Update entirely, which would leave you genuinely exposed to security vulnerabilities. They don't require technical expertise that takes months to develop. They require about 30 minutes today and a 2-minute habit check every time a significant update is pending. That is a reasonable ask for the return it delivers: a machine that is stable, an update pipeline that you participate in rather than one that happens to you. The knowledge that the next KB number that generates a wave of community reports will land in your awareness before it lands on your system. Microsoft controls the update schedule by default. You control it with 30 minutes of configuration. That gap between the default and what's actually available to you is exactly the kind of thing this channel exists to close. If your machine is running better after removing KB5074109, subscribe, because the next problematic cumulative update is already in testing, and you'll want to know about it before it installs itself. And leave a comment telling me which of the 3 reported issues you were seeing on your system: the boot time, the network drops, or the CPU utilization. The pattern of which hardware is most affected helps everyone watching figure out whether their machine is in the risk group for the next one,